Hello student, next topic is enthalpy for atomic or molecular changes. The first one is enthalpy of ionization. Enthalpy of ionization. Now we will use the same shortcut for remembering the definition of enthalpy of ionization. Enthalpy change that accompanies the ionization of 1 mole of gaseous substance is called as enthalpy of ionization, delta H ION. 1 mole of gaseous substance is called as enthalpy of ionization. So enthalpy change that accompanies the ionization of 1 mole of gaseous substance is called as enthalpy of ionization. Enthalpy of ionization is shown by delta ION H or delta H ION. Now see the example. Ionization of sodium, Na, this is gas, it forms Na plus gas plus 1 electron. Enthalpy of ionization for ionization of sodium is equal to 494 kilojoule per mole. 494 kilojoule per mole. Now this is the enthalpy of ionization. If the neutral atom gains electron, that the enthalpy involved will be called as electron gain enthalpy. For example, in case of chlorine atom, chlorine gas, or if we want to define the electron gain enthalpy, the enthalpy change that accompanies when the neutral atom gains electron, to form anion will be called as electron gain enthalpy. Now in case of chlorine gains 1 electron, chlorine gas plus 1 electron, it will form chlorine anion gas state. Now enthalpy change will be called as electron gain enthalpy, and that is equal to minus 349 kilojoule per mole. Okay, so this was about the ionization enthalpy and electron gain enthalpy. Now see the next one. Enthalpy of atomization. Enthalpy of atomization, delta H ATOM. Enthalpy of atomization is shown by delta H ATOM. Atomization. Enthalpy of atomization. Enthalpy change that accompanies the atomization of what? 1 mole of gaseous substance. 1 mole of gaseous substance is called as enthalpy of atomization. It is shown by delta H ATOM. Enthalpy of atomization. Now see the example. Formation of atom from the molecule. The molecule is being converted into atoms. So see the first one. In case of Cl2 gas, this Cl2 is gas, it is in molecular form. Now this Cl2 split into atoms, 2Cl chlorine gas. Now this 2Cl atoms we are getting 2 chlorine atoms. So formation of atom from the molecule is called as atomization. Now the enthalpy change is called as enthalpy of atomization, delta H ATOM, and that is equal to 242 kilojoule per mole. 242 kilojoule per mole. Now see another example of methane, CH4 gas. The formation of atom from the molecule, formation of carbon atom, and formation of 4 hydrogen atom from the methane molecule. So it will form carbon gas plus 4 hydrogen gas. Enthalpy involved is called as enthalpy of atomization, and is equal to 1660 kilojoule per mole. 1660 kilojoule per mole. So enthalpy of atomization is enthalpy change that accompanies the atomization of 1 mole of gaseous substance is called as enthalpy of atomization. So these were the two examples of atomization, and enthalpy change is called enthalpy of solution, delta HSOLN, enthalpy of solution. Now the enthalpy change that accompanies when 1 mole of substance is dissolved in, 1 mole of substance is dissolved in specified amount of solvent, specified amount of solvent is called as enthalpy of solution, is called as enthalpy of solution. Enthalpy change that accompanies when 1 mole of substance is dissolved in specified amount of solvent, the enthalpy change will be called as enthalpy of solution. Now when see the example, NaCl solid plus aqueous, I am using AQ or aqueous for water, it will form NaCl aqueous. Enthalpy change will be called as enthalpy of solution, and enthalpy of solution for NaCl is equal to plus 4 kilojoule per mole, plus 4 kilojoule per mole. Now when the ionic solid dissolved in water, it dissociates or it dissolves in water in 2 steps. See these steps, I will show these steps. Enthalpy of solution definition is enthalpy change that accompanies 1 mole of substance when 1 mole of substance is dissolved in specified amount of solvent is called as enthalpy of solution. So this is the example we have shown for enthalpy of solution when NaCl is dissolved in water. So it will form NaCl aqueous, and enthalpy of solution for NaCl is 4 kilojoule per mole. See the next example. Consider ionic solid. When ionic solid is dissolved in water, it dissolves in water in 2 steps. Now consider this ionic solid as mx. Okay. Now this mx will first dissociate into ions. It will dissociate into ions. So it will form m plus ion plus x minus ion, m plus ion plus x minus ion. Now in second step, the ions are hydrated by water molecules. Ions are hydrated by water molecules means the water molecule will surround the ions. M plus ion and x minus ion will be surrounded by water molecule, and that process is called as hydration. The process is called as hydration. Now the enthalpy change when the ionic solid dissociated into ion is called as crystal lattice enthalpy or delta LH. It is called as crystal lattice enthalpy or delta LH. I will write here crystal lattice enthalpy or delta LH. Okay. Now in second step, the ions are hydrated by water molecule. See here, m plus ion are hydrated by x number of water molecule. So it will form m hydrated by x number of water molecule, and charge on the ion is positive. So it will form the ion like this. In second case, the second ion, anion x minus, is hydrated by water molecule, and what number of water molecule is y. So it will form x hydrated by water molecule, number of water molecules are y, and overall charge on the ion is negative. Now enthalpy change involved in this case is called as enthalpy of hydration. It is called as enthalpy of hydration, and it is given by delta H HYD, enthalpy of hydration. Enthalpy of hydration is called as enthalpy of hydration. Now this crystal lattice, this enthalpy of solution is sum of crystal lattice enthalpy and enthalpy of hydration. The total enthalpy of solution, is the sum of crystal lattice enthalpy and enthalpy of hydration. Now the crystal lattice enthalpy for the first step, or for NaCl, or for ionic solid, we can say is plus 790 kilojoule per mole for NaCl, and the enthalpy of hydration is minus 786 kilojoule per mole for NaCl, in case of NaCl. So we can easily find out the enthalpy of solution for NaCl. So see here, enthalpy of solution is equal to crystal lattice enthalpy plus enthalpy of hydration. Now this crystal lattice enthalpy for NaCl is given 790 kilojoule per mole. Okay, and crystal lattice enthalpy of hydration for NaCl it is also given, that is minus 786 kilojoule per mole. Now we can find out the enthalpy of solution for NaCl. Now this will be equal to plus 790 kilojoule per mole, will take common outside bracket, minus 786, this is kilojoule per mole. So the enthalpy of solution for NaCl will be equal to plus 4 kilojoule per mole. So in this way you can find out the enthalpy of solution. Enthalpy of solution is sum of crystal lattice enthalpy and enthalpy of hydration. And if you know about the crystal lattice enthalpy and enthalpy of hydration, you can easily find out the enthalpy of solution for any ionic compound. So this was about the enthalpy for atomic and molecular changes. Remaining part we will see in next lecture.